The James Webb Space Telescope, JWST, was designed to peer into the earliest light of the cosmos, and it has now delivered data so unsettling that a Nobel Prize-winning physicist has broken his silence with one simple, terrifying message: this is not our universe. What exactly did the James Webb Telescope find at the very edge of everything, and why are scientists warning that it could rewrite the very foundation of cosmology as we know it? Keep watching, because what you're about to hear changes everything. In a corner of the sky filled with ancient light, the James Webb Telescope captured what looked like a simple yellow splotch. But when astronomers took a closer look, their assumptions collapsed. That tiny glowing blob wasn't just another galaxy. It was the most distant galaxy ever seen, formed just 290 million years after the supposed birth of the universe. But here's the impossible part: it's too massive, too bright, and too evolved to have formed so soon after the Big Bang. By our current theories, there simply wasn't enough time or matter to form galaxies like this in the early universe. And yet, here it is. And it's not alone. Webb has now found dozens more just like it, each one a cosmic paradox, breaking every rule we thought we understood about the early universe. Scientists began to dig deeper, and what they found was even stranger. Some of these early universe objects aren't just massive, they're completely foreign to anything we've seen before. Unlike normal galaxies, which convert about 10% of their gas into stars, Webb discovered at least 3 galaxies that have turned 100% of their matter into stars. No gas, no dust, just pure, blazing starlight. That's not just unusual. It's impossible according to every existing model of galaxy formation. So now, scientists are asking a far more terrifying question. What if these aren't galaxies at all? What if we're not seeing the early universe but something else entirely? A structure from another dimension, a remnant of a previous cosmos, or an intrusion from another universe altogether? To understand why this is shaking cosmology to its core, we need to talk about the Hubble sphere and the observable universe. The farther away an object is, the faster it moves away from us due to the expansion of space. At a certain point, called the Hubble sphere, galaxies are moving away from us faster than the speed of light. Common sense says we shouldn't be able to see those galaxies, yet we can. That's because space itself is expanding, and the boundary of what we can see keeps stretching. But beyond that boundary lies something terrifying, a region of the universe that we will never reach and that will never reach us. And yet, the James Webb Telescope is now picking up light and signals from these impossible zones, light that should never have reached us, which leads to one conclusion: we are seeing beyond the edge of our universe, and no one knows what lies on the other side. Webb's data is forcing scientists to ask the unthinkable: what if the universe never had a beginning? Some Nobel laureates are now openly questioning the Big Bang model. Because if galaxies could form faster than physics allows, if light can reach us from beyond cosmic boundaries, and if structures appear that defy time scale and mass, then maybe we've misunderstood everything. Maybe the early universe isn't early at all. Maybe what we're seeing isn't a timeline but a fracture, a place where 2 universes overlap, or worse, where something far older than our universe is bleeding through. Whatever it is, it doesn't fit into our models. And it never will. Among the James Webb Telescope's most overlooked discoveries is not a visual image but a strange frequency. While measuring the background noise of the universe, Webb's instruments detected a faint rhythmic oscillation, one that does not match any known cosmic phenomenon. It's not a pulsar, it's not gravitational waves, it's not cosmic microwave background distortion. This frequency repeats at precise intervals, as if it were generated. Some astrophysicists have started calling it the heartbeat beyond time. Others are more cautious, suggesting it might be a signature of exotic matter, something that could exist only outside the boundaries of our universe. And here's the chilling part: this frequency is not random. It follows a mathematical pattern, as if something or someone encoded it to be discovered. One of the telescope's unexpected findings is a huge imbalance between what we see and what we feel. Galaxies located at the farthest distances appear to have enough gravity to bend light, distort space, and even affect surrounding structures, yet no visible matter is present. This isn't just dark matter. It's something else. Some researchers now believe Webb is detecting massive gravitational anomalies that don't correlate with any known source. These phantom mass fields act like cosmic fingerprints, pressing down on space-time from a place we cannot see. But where are they coming from? Some theorists are beginning to suggest the unthinkable. We're seeing the shadow of another universe colliding with our own. What if everything we see has a mirror image we cannot see? Not metaphorically but physically. A fringe theory once dismissed by mainstream cosmologists is gaining traction again, that there exists a mirrored universe where time flows in the opposite direction and the laws of physics run backward relative to ours. What's changed? The James Webb Telescope has captured evidence of particle behaviors and rotational patterns in distant galaxies that suggest asymmetry, as if two different cosmic systems are overlapping. It's as though our universe is being pulled in one direction while another, just out of reach, is moving in reverse. If true, we may not be alone in the multiverse. We may be entangled with a shadow reality that reflects our own. In a final twist, one of Webb's long-range instruments was tracking a light signature from the edge of the observable universe. It was expected to fade. It was expected to disappear forever, as most. It was expected to fade. It was expected to disappear forever, as most light from distant sources eventually does. But then, something unprecedented occurred. The signal reappeared. Not from the same direction, and not from the same moment in cosmic time, but with the same spectral fingerprint. The same light signature, as if it had somehow rebounded, echoing across dimensions or timelines. This anomaly isn't something the current laws of physics can explain. If it truly is the same light, reflected back from some unseen boundary or mirrored realm, then it suggests the universe isn't open and infinite as we've always believed. It's curved, finite, and perhaps more importantly, interactive. That reflection raises two haunting possibilities. Either the light curved back through space itself, suggesting a closed, spherical universe, or it struck something. Something at the edge. A structure, a membrane, or a wall. But what kind of wall reflects light across billions of light-years and millions of years of time? That question alone has left cosmologists deeply unsettled. If this structure exists, it would be the first observational evidence of what theoretical physicists have speculated for decades, the brane theory from string theory. According to this model, our universe may be a three-dimensional bubble or brane floating within a higher dimensional space, one of many, like bubbles in a cosmic foam. If that's true, then the light may have bounced off another brane entirely. In other words, another universe. For decades, the multiverse was relegated to the realms of science fiction and theoretical speculation. But the James Webb Telescope is giving us observational hints, breadcrumbs leading toward a reality more complex, more layered, and perhaps more dangerous than anything we've imagined. There is a growing consensus among a small but vocal group of physicists. Webb has inadvertently pierced the veil. By reaching further into time and space than any telescope before it, it may have caught a glimpse of the scaffolding behind our reality. Some even suggest that the anomalies aren't accidents or glitches, but signals, intentional or not, from something beyond. And that brings us to perhaps the most disturbing part of all, the implications of these discoveries on the nature of consciousness and observation. You see, every cosmological model assumes a passive universe, an indifferent cosmos that exists whether we observe it or not. But quantum mechanics has long hinted at something stranger. That observation affects reality. That on the smallest scales, particles exist in superpositions, many states at once, until they're measured or observed. What if this principle extends far beyond atoms? What if consciousness, or the act of observing, plays a role in shaping the universe itself? The Webb telescope is a massive observer. It watches the edge of space with unparalleled precision. What if it didn't just discover the edge, but altered it? Some fringe theorists are now proposing an even more radical idea, that by looking so far, by collecting light that was never supposed to be seen, we've triggered something. Awakened it. A sort of cosmic observer effect, but on a universal scale. Evidence? In addition to the heartbeat beyond time and the reappearing light signal, Webb has also detected a slow drift in background radiation. A wobble that shouldn't exist, unless the fabric of space itself is changing. Could it be that the very act of seeing into the unknown is forcing the universe to adapt? This theory may sound outrageous, but it's not without precedent. In quantum physics, measurement collapses wave functions. Could something similar be happening across space-time? Could our technology be collapsing probabilities into realities we were never meant to touch? If so, then the phrase "this is not our universe" becomes more literal. It's not just that the universe has changed, it's that we've entered into another one. Or worse, merged with one. One where the laws are different. Where the constants of nature aren't so constant. And the signs may already be showing. Particle accelerators like CERN have reported subtle deviations in the behavior of muons, short-lived particles whose properties appear to defy the standard model. And now, Webb is showing similar inconsistencies on the cosmic scale. Gravitational lensing that doesn't align with visible mass, thermal radiation where no stars exist, and ghostly halos around galaxies that suggest they're not just rotating, but vibrating, tugged by forces beyond our comprehension. This growing stack of evidence is forcing a paradigm shift. Cosmology, as it was taught a decade ago, may already be outdated. Textbooks that state the Big Bang is the origin of all things may need to be rewritten, not because the theory is entirely wrong, but because it's incomplete. It describes only the local story, not the larger saga unfolding beyond the veil. And what about time? One of the most baffling findings from Webb is the distortion of time around some of these ancient, massive objects. Light from them doesn't just appear old, it appears inconsistent. In some cases, the redshift doesn't match the expected age. In others, time seems to dilate and contract in inexplicable ways. Some physicists are now considering whether time itself flows differently in other regions of space, possibly influenced by proximity to parallel universes or dimensional rifts. This opens a door to a truly alien concept, cosmic time zones. Not in the earthly sense, but regions of the universe governed by entirely different temporal mechanics. A minute in one universe could span eons in another. And if we are receiving signals across these boundaries, then we are effectively communicating, not just across space, but across incompatible frameworks of time. And if that's the case, then what we interpret as ancient may not be ancient at all. Some of the structures Webb is detecting might not be remnants from the early universe. They could be recent events, bleeding in from an adjacent cosmos where time flows differently. This challenges our ability to even determine what early or late means on a cosmic scale. And yet, despite the fear and uncertainty, there is a sense of wonder. For all the terror these findings inspire, they also illuminate our position in the cosmos. We are not the center. We are not even the full story. We are a fragment, perhaps even an accident, of something infinitely larger. And through the lens of the James Webb Space Telescope, we are finally beginning to see that truth. So, what happens next? The scientific community is splitting. Some researchers are calling for caution, urging the world not to jump to conclusions until more data is analyzed. Others are urging boldness, suggesting new missions to probe these anomalies directly. There's talk of successor telescopes, of probes to the outer solar system, of quantum satellites capable of scanning gravitational frequencies in the void between galaxies. And quietly, behind closed doors, philosophical debates are re-emerging in academic halls. Debates about the nature of existence, the role of consciousness, and whether we are alone, not just in terms of life, but in terms of identity. If this is not our universe, then where do we belong? Are we the product of our universe, or merely visitors within it? Some say this is the beginning of a new era. The Age of Revelation. An epoch in which the universe reveals itself not as a static object, but as a living, shifting sea of realities, folding and unfolding in infinite combinations. A place where universes birth each other, where dimensions bleed, and where light is not just a wave, but a message. Others aren't so hopeful. They see the data as an omen, proof that something has gone wrong. That reality is breaking down, that we've reached the edge not of the universe, but of understanding itself. One thing is certain, we cannot go back. The light has reached us. The echo has spoken. And whether it's an invitation, a warning, or a coincidence, we've seen it now. And it has seen us. In the silence that followed these revelations, one truth began to take root, a truth more profound than any theory, more disquieting than any alien encounter. We are not the authors of our cosmic story. For the first time, humanity is forced to confront the possibility that we are not even the protagonists. For all our scientific instruments and theoretical frameworks, we still understand only a fraction of what the universe truly is. The James Webb Space Telescope was meant to answer big questions. How did galaxies form? What did the first stars look like? Was there ever life beyond Earth? But what it has done instead is something much more significant. It has cracked open the sky and exposed the seams of reality. Take, for instance, the discovery of high metallicity elements in galaxies that should be almost entirely primordial. These elements, iron, oxygen, even hints of complex molecules, should not exist in such abundance so soon after the Big Bang. Their presence implies not just rapid star formation, but multiple generations of stars having already lived and died. It's as if these galaxies had an entire evolutionary history compressed into a sliver of time. That shouldn't be possible, unless time itself operates differently in these regions. Or unless these galaxies are not part of our universe at all. And then there's the symmetry problem. Webb's ultra-deep field images have shown a baffling imbalance in cosmic structure. Galaxies are not scattered randomly, nor are they evenly distributed. They form vast filaments, massive voids, and intricate lattice-like webs.